Today, we're going to pull back the curtain on some of that invisible magic that happens every time you load a web page, send an email, or stream a video. We're talking about the application layer. Basically, it's the gateway that your favorite apps use to connect to the rest of the world.
I mean, really, have you ever stopped to think about it? You type a message, you hit send, and somehow, poof, it just appears on your friend's phone halfway across the globe. How does your app even know what to do? Well, that's exactly what we're going to break down today. So let's just dive right in. All right, so to really get our heads around the application layer, I want you to picture it as a personal concierge, but, for your software. Now, the official textbook definition says it's a set of protocols or rules that software uses to get online. But honestly, the concierge analogy is way better. When an app needs to do something on the internet, it doesn't just wander out there on its own. Nope. It goes straight to the application layer, our concierge desk, and makes a request. It's the only part of this whole system that our apps talk to directly. So what's on this concierge's job description? Well, for starters, it puts the initial headers on our data. Think of it like slapping the to and from addresses on a package before you mail it. It's also smart enough to know which specific app on the other end is supposed to get the message. And, crucially, it talks to the next layer down, the transport layer, to sort out all the rules for the conversation. This is where all the stuff we actually use, email, the web, you name it, really lives. Okay, so if you're building an app, you have to make a huge choice right at the beginning about its basic structure, its architecture. And that choice pretty much boils down to two main options: client/server or peer-to-peer. So on one side, you've got the classic client-server model. This is a totally centralized setup where one big, powerful server provides a service to lots of different clients. Think of a bank, right? One central vault serving tons of customers. Then, on the other side, you have peer-to-peer, or P2P. This is completely decentralized. All the individual devices, which we call peers, talk directly to each other. There's no middleman. It's more like a neighborhood potluck where everyone just brings and shares food directly with each other. And what's really fascinating is just how differently these two models work in practice. With client/server, that central server is always on, just sitting there waiting for requests. And it's the client that always has to start the conversation. But that can create a massive bottleneck if the server gets too popular. For a P2P network, though, the peers are always coming and going. They're not online 24/7, and any peer can kick off a conversation. This makes the whole system incredibly flexible and scalable. Okay, enough theory, let's make this real. How does this actually play out in the apps you're using every single day? Let's look at a couple of perfect examples. First up, the web browser. This is the textbook example of a client/server application. Your browser, Chrome, Safari, whatever you use, is the client. The process is actually pretty straightforward. You type an address into your browser, the client. That client then shoots a message out to the website server asking for the page. The server, which has been waiting for exactly this kind of request, responds by sending back all the files, the code, the images, everything. And finally, your browser puts it all together so you can see the website. Simple, direct, classic client/server. Now, let's flip the coin over and look at the other side, a peer-to-peer application. And the best example of this is file sharing. And this is where you can see how radically different it is. In a P2P network, there is no big central server that has all the files. Instead, every single user's computer, every peer, stores and shares files. So your P2P app searches across all the other computers online to find what you're looking for. Once it finds it, it creates a direct connection between your machine and the other person's machine to transfer the file. It's a true distributed network. So we've got our apps and we know how they're built. But there are a few absolutely essential services running in the background at the application layer that make the whole thing work. They're kind of the unsung heroes. And the most important one is probably the Domain Name Service, or DNS. See, computers don't know each other by name. They use these long numerical IP addresses. DNS is that critical translation service that takes the human-friendly names we type, like google.com, and turns them into the IP addresses computers actually need to connect. Honestly, the easiest way to think about it is this. DNS is the internet's phone book. You look up a friend's name to find their phone number, right? Well, your computer looks up a domain name to find its IP address. Without it, we'd all have to memorize these crazy long strings of numbers just to check our email. No thank you. Okay, we have covered a lot of ground, so let's do a quick lightning round to make sure these key takeaways really stick. First question. In any conversation between two machines, how can you tell which one is the client and which one is the server? It's actually super simple when you boil it down. The client is the one that starts the conversation. The server is the one that's just sitting there waiting to be contacted. The client asks, the server answers. That's it. But hang on a second. If P2P is all about equals talking to each other, why do we still use the words client and server when we talk about it? That seems like a contradiction.
Well, it's because even in a peer-to-peer system, for any single specific transfer, those roles still exist. They're just temporary. When you download a file from someone else, your computer is acting as the client because it initiated the request. The computer sending you the file is, just for that moment, acting as the server. In the very next interaction, those roles could completely flip.
All right, final point of clarification. We've been throwing the word architecture around a lot. What's the real difference between network architecture and application architecture?
Network architecture is the big picture. It's how we organize the entire communication process into different layers, like the 5 layers of the internet. Application architecture is much more specific. It's the design that a developer chooses for their particular app. Are they going with a centralized client-server model or a decentralized peer-to-peer one?
And that really brings us to our final thought. For decades, the internet has been completely dominated by the client/server model. But now, with the rise of all these decentralized technologies, P2P is making a massive comeback. So the big question for the future is, which of these 2 core structures is going to define the next generation of our digital lives? Definitely something to think about.